application, a real time application of the normal distribution. So we are going to do it in R. I'll open the last one which we opened, and then as usual I have to run the first line. That is, I have to get the folder, or this I will skip for the time being because it has already been demonstrated. So now I'm going to read a file and I'll call that RF. Okay, so read.csv, open a bracket, within quotes I have to give the file name. It's rainfall data. Rainfall. Okay, so I'll go there. .csv, and I should not forget to type header equal to true. Rainfall. Comma separated values, and I'll save it. I'll now read it into R. Using the command read.csv, name of the file is csv, run it. Yeah, it's read. Now I look at the variables. Look at the variables. Okay, so now we have the variables. And the last one is the annual rainfall. So this is monthly rainfall. I'm interested only in the annual rainfall, which is the last variable, which is the title of the variable is annual. So to get a plot of that data, so I can plot it. So the name of the file is rf dollar. Name of the variable is annual in caps. Annual in caps. So I get a plot of that data and see that the data has got a very surprisingly, it's got a pattern. And this is rainfall in Karnataka, right? Sorry. This is rainfall for the whole country, whole state. So now I'll take rainfall. Yeah. Now what I'll do is, now you'll see me using a particular variable that is here. Now I will take what is the average rainfall for each year. So that will aggregate over all the districts and I'll take an average. Okay. So that data is not the right data. So now I'll go to R. I'll do one small step. Right? I'll do one small step. What I'll do, I'll call it rf.1. That's my new variable. rf.1 is my new variable, which is nothing but aggregate. I'll take this annual. Annual by equal to list year. RF dollar because they're all in caps. So when I give an aggregate, I should say what is it going to be? It's going to be function equal to mean. So now I'll get a mean rainfall which will aggregate across all the districts and then finally give me a mean rainfall which I'll now call this should be in lowercase, I made a mistake. This should be very case sensitive. And this is yes, it is run. Now let us have a look at this data. So for look, I'll use view. And now I will look at rf.1 because that's a new variable that I've created. The new variable that I've created. It's getting prepared. It's the rainfall data from 1950 to 2014. Now I've created one column. So I'll call this year and I'll call this mean rainfall. So please recollect what I did earlier. So what I'll do is I'll say call names, the name of the file, .1 which I'm going to rename, equal to, I'll put a C and the first column will be year, I'm not putting caps, and the second column will be rainfall. Okay. So now, if I now go and look at the names, .1, then I will get year and rainfall. Now I'll plot it. Line, color, equal to red. So I get a line. You see the rainfall is not following any pattern. So the first thing that I'll do is I will now look at the distribution of this data. So I will say hist. So please recall what I did. Hist. This is the variable that I want plotted. I can run it and I've got a fairly good distribution. It's fairly normally distributed. Now I can, if I want more class intervals, I'll say comma 20 class intervals. So you'll get a little more rich. So you get a kind of pattern, right? And if I want to convert this into probabilities, I'll just say comma PROB equal to true. Now, so what you now get is you will get the probabilities associated with it. Earlier it was the numbers, now you get the probabilities, right? Then you can also look at the distribution. So it is plot density sorry, I forgot the name of the variable. Okay, so it kind of gives you kind of normal distributed variable. Now in the earlier case, what we did was we gave the mean and the standard deviation and generated the data. Now we've got the data and we need to fit a distribution. So now I will first calculate the mean of this data, and I also calculate the standard deviation of this data. Okay, so the mean is 1148 1149, and the standard deviation is 154.15. Okay. Now, let us assume that, now let's go back to this distribution. Now let us assume that the mean is 1150. Now I want to predict what is the probability that the yields will fall below 20%. So what is the probability that the yields will fall below 20%? Okay, so please recall what we did earlier. So I will use what is called as P norm. P norm, open a bracket, variable. No, sorry, mean. Dot 959. Standard deviation 154.115. Right? And here I want, now here we just discussed this earlier. We are talking about 80% of this. So let's just calculate what that would be. 80% 0.8, that means 20% for 0.8 into 1148.959. So I would be interested in knowing what is the probability that yields will fall below 920. Right? Okay, so 920 I'll put over here. Just see, I use the P now and put the number. Because anybody in the agriculture business would want to know what is the probability that rains in Karnataka will be below 80% of the mean. So I get a value of 6%. So the prob 920, now I'll do this again. So what I'm doing is Control C. Then I'll do AB line. And I want a vertical line. I can put colors also of 920. Okay, effectively, this is what I'm going to do. So I want to find out what is the probability that yields will fall below 80%. I'll draw the 80% line with this AB line, with the vertical line, and that says there you are. So the probability that yields will fall 80% of the mean is 0.06. Very remote, possibly just 6% probability that yields will fall below 80% of the mean. Okay. So another very useful app. So you can all do. Later we will test whether this data really follows a normal distribution. So now I will learn, since I will need agricole, I'll also do a skewness measure just to check whether the data is normally distributed or not. This is my variable. Okay, so skewness is not exactly 0, but it's quite close. And I will also look at kurtosis. Kurtosis is 0.2. So the data is quite normal, quite normally distributed. That we will get into the details of estimating how a distribution is normal, or whether the distribution, the data actually follows a normal distribution. As we would discuss the other distributions, then we can come to this. Now here is a simple application. This is weather data, rainfall, and they have a concept called as weather insurance. There's something called, what insurance agencies give is called weather insurance. Weather insurance. Okay, this is an actuarial formula which I'll just apply directly. The formula is loss cost. Loss cost is equal to, in bracket, y bar minus c, coverage, into A plus D is a probability. D is the height of the, at the coverage, height of the coverage into standard deviation. So this is the formula. So the information that we know, we've got the mean, we've got the coverage we've taken as 80%. Normally coverage is given for 80% of the mean. So we've got that also, 920. We have got the, so we've got y. Y is equal to y is 1148.959. Right? The coverage is 80% of that. Coverage is 80%. Because normally insurance cover is 80% of the mean, long-term mean. 80% of y, which is equal to 919.167. Okay. Then we have A, which is the probability. A, which is the probability. So probability will be P norm. P norm 0.919. Copy this. Given this mean. And this standard deviation. Okay. So it should also give the standard deviation S. S is equal to country. Okay. So we can get A here. Right? And D is equal to D norm. In brackets. So I want to find out D norm, that is at this value, at the coverage. With this mean and the standard deviation, which has already been specified. Okay. So we'll now get the, this of course is got. Now we'll calculate A, and we'll also calculate D, and we shall put it into a formula. So if you want to see what these values are, just see this part. 0.06 that we already got, and this is the D norm, is the height of the distribution at that point. 0.008, and now I'm going to use the formula. So loss cost, loss cost is equal to y minus c. C, it's actually c minus y bar, sorry. It's c minus y bar. So formula is c minus y. So it will be c minus y. C is the coverage. Y is the long-term mean. Okay. This will be multiplied by A, which is already calculated and saved over here, plus D, which is also calculated and so, sorry, D, which is calculated with a small d, multiplied by multiplied by standard deviation S. So it's been calculated. So we'll get the output in LC, which will tell us. So the loss cost or the cost of the risk involved given that distribution is 15.48 millimeters. So 15.48 millimeters will be the amount of premium that the weather insurance company will collect in terms of that will be converted into a value. Each unit, each millimeter will have a value, and that value will be taken as, so if they are covering your cost. Now supposing you're going to get your cost of production, let's assume that your loss cost is calculated as 15.44.489. Like for instance, if your coverage is again related to the loss of yield. Now, supposing you have what do you call, taken an insurance for 10,000 rupees, right? If you're taking an insurance for 10,000 rupees, then in order to pay you 10,000 rupees, the premium that they collect, that is called the loss cost premium, will be 15.489 units. So that units will have to be converted in terms of value, and to get a coverage of 10,000, that much of value will be calculated. Now to see, I mean the value, I'm not, unless we have a real example, we can't tell you, but I can also tell you what the premium rate will be. The premium rate will be 15.489 divided by the coverage, which is 919, because this is how much. Below this only you will get any kind of, so whatever that value, so the premium rate will be 1.68%. So 1.68% of 10,000 rupees will be roughly about 100 and let's see. So the premium will be roughly, to give you a coverage of 10,000 rupees, they will collect 168.5 rupees per acre from the farmer, so that he gets a coverage of 10,000. 10,000 will usually be his cost of cultivation, which the government ensures with the help of this crop insurance, with the help of weather insurance. So, but one thing is these probabilities are all depending. This A depends on what distribution you have considered. So that is what you need to understand. What you need to appreciate in this study is to find out what is the distribution, how do you decide which is the appropriate distribution. That we do that later. Now you should be now familiar with the normal distribution, its properties, how it is to be estimated, and how it is to be used in application. Later we shall go to find out which is, how do you determine whether this is really a normal distribution or not. That we will do after we finished all the other continuous distributions. Thank you.